Okay, before I actually start talking about parallel lines, I just want to go over some vocabulary with you. Anytime you have a line that intersects two other lines, we call that line the transversal. There's some vocabulary that will relate the angles at the top to the angles at the bottom, or left, right, whatever the orientation is. So the first one I want to show you is corresponding angles. Corresponding angles is actually my favorite one, makes the most sense to me, are the angles that are in the exact same location. So corresponding is going to be the same location. So for example, angle 2 here, if I traced angle 2 and if I trace this whole intersection and slid it down here along the transversal, I would find that angle 2, which is on the top right, would land on angle 6, which is on the top right. So angle 2 and angle 6 would be considered corresponding angles. They're in the same location. Okay? Now I've got some other angles here that I'm going to actually help you understand this vocabulary by breaking it down a little bit. I've got alternate angles and I've got consecutive angles. Alternate angles are going to be on different sides of the transversal. Okay, alternate means different sides. Okay, I'll show you what I mean in a minute there. Consecutive, that refers to the same side of the transversal. Okay, and then I've got this other vocabulary here. Interior. Okay, interior is going to be on the inside. And exterior is going to be on the outside. So when I was learning this vocabulary, it was easier to break it down into the two parts to decide which angle is what. Okay, so here's what I mean. Alternate interior. So when I say alternate, I mean different sides of the transversal. So one angle will come from that side of the transversal and the other angle will come from that side of the transversal. Okay, interior. Interior means on the inside of the two lines being intersected. So at the bottom here, 5 and 6 are interior angles, and at the top intersection, 3 and 4 are interior angles. So alternate interior angles. So for example, 4, and then that's on the interior, and then on the other side of the transversal is 5. Okay, 3 and 6 would also be alternate interior angles. Now consecutive interior angles, those are going to be on the inside, so again we're looking at 3 and 4 are interior, 5 and 6. But this time they're going to be on the same side of that transversal. So for example, on the interior there we've got angles 4 and 6. Those are consecutive interior. Or if I look on this side, I've got 3 and 5. So 3 and 5 would be considered consecutive interior angles. Okay, alternate exterior, same idea except now we're on the outside. Okay, so angles 1, okay, that's on this side of the transversal, angle 1, and then when I look in the alternate side of the transversal, on the other intersection, down here I get angle 8. Okay, so angles 1 and 8 are alternate exterior, or angles 2 and 7. Okay, consecutive exterior angles, this time we're doing the same side, still looking at exterior. So consecutive exterior angle, same side would be like 2 and 8 or 1 and 7. Let's do angle 2 and angle 8. Those are consecutive, same side, exterior on the outside. Okay, and then I've added a couple other ones here from Unit 1. This is a review from what we just did. Vertical angles and linear pair. They're a little different because they're from the same intersection, but you'll see why I included them in this list. Okay, so angle 1 and angle 4, for example, those are vertical angles. Angles 2 and 3, 5 and 8, 6 and 7, those are all vertical angles. So let's see, let's do angle 5 and angle 8, vertical angles. Okay, linear pair. Linear pair also comes from the same intersection. They're the ones that make that straight line. Remember, they're supplementary. They add up to 180. So 5 and 6 would be a linear pair. 2 and 4 would be a linear pair. Okay, I've got a whole bunch of them. Let's do 1 and 3. That's a linear pair. It doesn't matter which pair you include. Okay, so now that we've reviewed the vocabulary, I want to talk about, well, what if we know that the two lines are parallel? So I'm going to show you some theorems here that I've written out. And what I've done is I've highlighted the hypothesis in them. These are conditional statements, okay? These are theorems that you'll find in your book or online. If parallel lines are cut by a transversal, then corresponding angles are congruent. So these are just theorems that tell you what you know about the relationships between these angles. What I want you to notice, though, is that each one of them has the same hypothesis. The hypothesis is that parallel lines are cut by a transversal. So rather than actually giving you the theorems for your notes, what I've done is, if you notice, parallel lines cut by transversal, corresponding angles congruent. Alternate interior angles are congruent, and alternate exterior angles are congruent. So what I've done for your notes here is I've gone ahead and organized them into a list. And vertical angles is included here as well, okay? Although it is special because it's not going to, when we get into the next couple standards here, it's not going to prove lines are parallel, but they are in this list of angles that I know are congruent. Okay, again, remember, this all assumes that you know that the lines are parallel. If lines are parallel, those lines that are cut by the transversal, then you can say that these relationships are true. So in other words, going back to this picture, I can't really put this there until I add this to the picture. If I know that these two lines are parallel, so you can see arrows like this, sometimes they're filled in. Okay, but when you see those symbols, if you're not told in the directions, look for the symbols. If you see the lines are parallel, then you know that all these types of angles are congruent. And when we start looking into algebraic expressions and angles, we're going to have to do some problem solving. And what we know about congruent angles is that when we set them up, what we'll be doing is setting them equal to each other. We'll put an equal sign between those two angles. Okay, now if we go back to this one, I only wrote out this one theorem, the last one here. If parallel lines are cut by transversal, then consecutive interior angles are supplementary. That's also true for consecutive exterior angles, and then of course we know it's true for linear pairs. We learned that back in Unit 1. So this list includes all types of angles that would be supplementary. Now remember, the definition of supplementary means that when I take the two angles, when I find their sum, when I add them together, they will equal 180. So that's how I'd be setting it up if I was looking for an equation to solve. Okay, so now let's go ahead and actually try one that involves a little problem solving. So this one, I'm giving you some algebraic expressions. Okay, in the directions I'm telling you that sorry about that. Okay, in the directions I'm telling you that lines A and B are parallel. So this symbol, remember, everything in geometry, the symbols look like what they are. So this says that if line A is parallel to line B. So I'm going to put that into my picture. I know the lines are parallel. And once I know the lines are parallel, I've got all those angle relationships that we just went over in mind, although you'll see that I really only look at the corresponding ones. I'm going to show you how I problem solve this. I'm going to get some tracing paper. Okay, so for starters, let's go ahead and put the angle measurements into the angle. So the measurement of angle 2 is 4x minus 3, and the measurement of angle 8 is 2x plus 9. So when you're trying to solve this problem, solve these algebraic expression ones, you're going to have to, this first step is going to be the most important one. So you're going to have to really put thought into this. Notice that when we're dealing with parallel lines, there's only two choices here. Either we're looking at congruent angles or we're looking at supplementary angles. Okay? But we've got to get that setup correct or we're not going to find the right solution. So let's look at this and see which one we think it is. Okay, now one technique I use that some students find helpful is tracing paper. Personally, how I do this is I pick one of the angles, it doesn't matter, the one up here, the one down here, and I'm going to slide it. What happens when these two lines are parallel is all the angles are either congruent or supplementary, right? So I just have to decide which one it is. Angle 2, when I slide this to the bottom, notice when the lines are parallel, watch what happens when I slide this along the transversal. Oh, look at that. The intersections are exactly the same. Okay, I'll do that again. This only works if lines are parallel. So if I slide this down here along the transversal, they're identical. Okay, so the angle that I just found is angle 6 is the corresponding angle. It was the one that was in the same location. So I'm going to move that 4x minus 3 to angle 6. Now that I've got it down here, I'm going to ignore that up at the top. All I care about is what is the relationship right here. Okay, remember my choices are that they would be congruent, in which case I'm going to put the equal sign between them, or they're going to be supplementary, in which case I add them and they equal 180. Well, looking at this intersection, if I can make that straight line like that, I'm looking at a linear pair. I'm looking at this situation. They were not vertical, so they're not equal. They're making that 180. So I'm going to add them together. 4x minus 3 plus 2x plus 9 equals 180. Okay, and then I'm going to go ahead and solve. So these terms are on the like side. I'm going to combine them. They're on the same side. And I'm going to subtract 6. Oh, I switched my colors here. My steps are now in black. Sorry about that. 174. And I sure wish I had a calculator with me. I'm going to have to divide by 6. Let's see. 6. This is going to be 2, 12, 5, 54, 29. Okay, so I got x equals 29. Now remember, I'm not done until I go substitute. So they asked me to find the measurement angle 4. I go and I substitute either way. I want to go and make sure that my math is right. So if I put 29 up into this angle, oh my goodness, let's see, 4 times 3120. I think that's 113. And then when I put it into this other angle, 2 times 29, that's 67. Okay, so when I substitute those into the angles, I got 113 up here for angle 2, and I got 67 down here for angle 8. Now if I add those together, I get 180, so that makes me pretty happy about that. They're asking me for angle 4. Angle 4 is actually the one that's corresponding to angle 8, so it will have the same measure as angle 8. So the measurement of angle 4 equals 67 degrees. and I feel pretty good about my answer.